Good morning. So I am with the EPA's Office of Air and Radiation in the Climate Change Division. I work on our national greenhouse gas inventory, the report of greenhouse gas emissions in the U.S. that's submitted to the UN annually. Today I'm going to talk a bit about EPA's data needs. I'll discuss our two key EPA GHG emissions data programs. I'll discuss some of the considerations for updating our national greenhouse gas estimates and some thoughts we have on policy-relevant measurement studies. So EPA needs greenhouse gas emissions data because it's fundamental for developing, implementing, and assessing policies and programs to reduce emissions. We can't wait for perfect information. It's not an excuse to delay action, so we base our emissions estimates on the best data and methods that are available at the time of their development. There are some general data quality requirements we consider for national greenhouse gas inventories. The data sets must be complete. We need to cover all anthropogenic sources and exclude natural sources. The greenhouse gas inventory is calculated over a time series from 1990 to the most recent year that we have data. And so we need consistent methods and data collection over time so that we can be reflecting real trends. We also require transparency. We have a lot of stakeholders that are very interested in the greenhouse gas inventory. There are a lot of researchers that use the inventory as well, and so we need to have methods that we need to be able to clearly document so that stakeholders can review and understand our methods. Uncertainties, of course, cannot be eliminated, but they should be quantified, managed, and reduced to the extent possible. In terms of resolution, spatial resolution is important at a less than national level for some applications, but not others. So for UN reporting, our emissions are at a national level. We should note that we do have some emissions estimates available at regional levels. So for oil and gas production, we have regional data on methane and CO2. For some of our ag sources, we have data available at state or county levels as well. The international and national reporting we do is annual. And then finally, in order to be able to connect emissions data to the activities and equipment that cause emissions so that the information can be policy and program relevant, we need data on units and processes for which we're estimating emissions. The two key greenhouse gas data sets that we have at EPA are the U.S. greenhouse gas inventory, which is the UN requirement for all Annex I countries to report annually, and then the greenhouse gas reporting program, which is reporting required by regulation. The greenhouse gas inventory is national level emissions. We've been developing the inventory for over 20 years now. It covers all U.S. anthropogenic emissions and sinks. It's based on kind of split into 4 different sectors, so energy, industrial processes, agriculture and land use, and waste. We cover CO2, methane, nitrous oxide, and the fluorinated gases. The methods that we use generally involve measurement-based emission factors, models, and then some data from the program I'll talk about next. We use a lot of national level activity data, so things like miles of pipeline, and then emission factors to apply to that activity data, so methane leakage per mile of cast iron pipeline, for example. And these are methods that are laid out in the IPCC guidance for greenhouse gas inventories. Again, it's a time series for the inventory, so 1990 to the present. Switching over to the greenhouse gas reporting program, that is a program that has been in existence for about 4 years now. It's based on a regulation that requires large facilities that emit over 25,000 metric tons of CO2 equivalent per year, to report their emissions and other related data to us. The reporting covers, we estimate, about 55% of direct U.S. anthropogenic emissions. An additional 30% of emissions are covered through reporting of indirect emissions by fuel and chemical suppliers. The reporting covers the same gases as the greenhouse gas inventory. The methods that facilities use to calculate and report their emissions include a mix of continuous monitoring, some periodic measurements and sampling, and then also engineering calculations and emission factors. The reporting has been annual since 2010 for some sources, 2011 for others. I'll give a brief overview of the results of the most recent greenhouse gas inventory, the national inventory reported to the UN. So you can see the time series from 1990 to 2012. Every year, CO2 dominates emissions, of course. It's about 80% of all emissions. Methane is about 9%, followed by N2O at about 6%. The total is generally around 6 to 7 billion metric tons of CO2 equivalent per year. There was a small decrease in emissions from 2011 to 2012. Over the full-time series, there's been an increase of about 5%, and then a decrease of 10% from 2005. This is the inventory that was published last April. Every year we develop and submit the inventory to the UN in April, and so in April of 2015, we'll be submitting the inventory for 1990 to 2013. Just showing the results a different way. So these are the emissions by sector. The top chart shows the emissions with electric power considered to be a separate sector, and the bottom chart shows the emissions from electric power split into the different categories. Switching gears to the data reported to the Greenhouse Gas Reporting Program. So these are emissions from facilities that are over the threshold that are reporting to the Greenhouse Gas Reporting Program. So these aren't the national level emissions, but for those large facilities. We're showing the total emissions with power plants being the highest source, followed by oil and gas, followed by refineries. And then also the average emissions per facilities are in the gray box. This is to give a sense of how the data is available. So we do have emissions mapped to location for GHGRP. The availability varies by source and the level of disaggregation of emissions. For some of the oil and gas emissions, they're available at the subbasin level, but for a lot of the facility level emissions, we've mapped them to the facility itself. So I think it can be useful if you're doing a study and see kind of a spike in emissions. You can go and look at the greenhouse gas reporting data and try to learn more about a facility that might be on site there. There's also very detailed data available on the emission sources and by activity. So you could click on a facility and look at total methane, total CO2. You could also look at it by process. So you could see the total emissions for pneumatic devices, per landfill, and things like that. We're always working to update our greenhouse gas emissions. It's a key part of the inventory development process. Every year we have an expert and public review and an international review where we get a lot of feedback from stakeholders on updated methodologies and on new data, and so we take that information into account and update the inventory. It's also a key part of the White House Climate Action Plan, which includes plans for EPA to update the inventory, including using new data from the Greenhouse Gas Reporting Program. So bottom-up calculations require numerous data inputs, but some are more difficult to collect than others. And a lot of the key gaps that we have in the inventory require low-tech or no-tech information collection. So some of the key information that can be used to update the inventory includes things like more detailed information on animal diets, on landfill soil oxidation rates, activity data and control practices for natural gas. These are all methane sources. That's because I work on methane, but the issues are similar across the different sources. And then some specific examples of the work that we're doing currently to improve the greenhouse gas estimates and the work that's planned. We'll be able to integrate a lot of the Greenhouse Gas Reporting Program data in the future. Some of it's already been integrated into the inventory. For key oil and gas information, the activity data is reported to us starting in 2015. So we've had emissions for quite some time, but we don't have the numbers of equipment. So that makes it difficult for us to recalculate emission factors or to update information across the time series. We'll also have improved information on landfill gas, including waste composition and gas capture, and then better information on coal mining that can be incorporated into the inventory as well. Another note on the Greenhouse Gas Reporting Program, they're also in the process of proposing updates to include additional sources. So there are some key sources in the oil and gas sector that we'll be getting improved information on through some of the proposed updates. Assessing external studies and incorporation of new data is a key part of the greenhouse gas inventory improvement. Recently, we had new data from API and ANGA on liquids unloading. We cross-checked it against what information we did have reported to the greenhouse gas reporting program and saw that it was an improvement. There, of course, are the EDF and UT Austin studies coming out that we'll be looking at as well. We've been improving our engagement with the top-down research community. We've been doing a lot of coordination internally with the EPA Office of Research and Development, which does measurement studies. We've been working with the Jacobs Group at Harvard on developing a methane gridded inventory with location-specific information. And so that will help with doing top-down comparisons where we see different emissions in certain regions. We'll have a better sense of what does the inventory report in that region. And then my final two slides will discuss the role of measurement studies in improving inventories. I've listed here 3 general types of studies. I know there are others. One would be studies that look at trends in atmospheric concentrations to assess effectiveness of global efforts to reduce emissions. Those would include studies that feed into the IPCC assessment reports. It's difficult for us to use those studies to improve the inventory. They're very useful for their specific purpose, but we can't really directly use them right now. Second, independent verification of inventory estimates through inverse modeling. An example could be the NOAA verification studies. They can provide us general conclusions about potential over and underestimates, but attribution right now is a bit of a challenge. So there's limited ability to pinpoint which data inputs need to be improved, though I think everyone's kind of working towards a place where we might be able to do some better pinpointing of emission sources. Finally, there's the direct measurement of specific activities, processes, and equipment to develop improved emission factors. Some examples of those would be UT Austin and EDF. So those can lead to direct improvements if the measurements are representative, but cost and access to facilities can be a challenge for those studies. We spent a lot of time reviewing new studies on greenhouse gas emissions and thinking about how the data can be used to improve our emissions estimates. We have some general thoughts and some key considerations for policy-relevant measurement studies. For top-down studies, using the right bottom-up inventory comparison is really important for us to kind of look at that data and compare it to what's in our inventory to see if it's an over or underestimate. So a lot of studies have used EDGAR, which is great because it has spatial data on emissions, but it's not the greenhouse gas inventory. It's not based on our emissions estimates, it's based on a different model. So when we see things that are comparing to EDGAR, it's helpful in knowing that EDGAR may be off, but it doesn't tell us anything directly about the US greenhouse gas inventory. Also, seasonal and regional variations are important. If a measurement's taken place in the summer at a certain region, we would need to know if it applies nationally and annually as well. Natural sources also have to be taken into account. So it's very important to clearly communicate assumptions and uncertainties. Finally, on bottom-up, providing information on the activities taking place at the time of measurement and their national and regional representativeness is important to us as well to directly translate things to the inventory. These are just some resources. So, thank you.
Thank you, Melissa. That was an excellent opening for what you should get some questions.
I was out of time.
We have a little bit of time for questions. She finishes a couple minutes here, and that's an excellent opening to where we're going to be going. I think you identified some key problems like attribution and those kinds of things. Are there any questions? Yes, sir. Please stand up, speak loudly because people can't. Everybody didn't have a microphone.
Can you say something about how you document the uncertainties?
Mm-hmm. So for every source in the greenhouse gas inventory, there's an uncertainty estimate. There's a chapter in the inventory that covers how uncertainty is calculated for the inventory as a whole. And then for each source category, there's information on uncertainty in general for that category. It doesn't include the full information because it is a very large report as it is, but there's other background data available. There's often references to where the uncertainty estimates come from or how they were calculated. The overall uncertainty for the inventory, I think, is around 5%. The methane sources, it's higher, and other greenhouse gases are higher as well.
Riley?
So there's a difference between addressing the independent checks on inventories and supporting mitigation. So for example, in the U.S. natural gas sector, there have been a lot of studies recently, or studies that are underway that assert there may be a long tail distribution in some of the sectors and sources. Can you say anything about EPA's plan? There is evidence of that tail distribution, how that affects future reporting and monitoring.
Right, so that is definitely something we're seeing across a lot of studies that we've seen recently. In terms of the greenhouse gas reporting, it's only facilities that are over a certain threshold, so that might be only capturing part of that distribution, and it's something that we're thinking about for developing national emissions factors, but we're still kind of early in the process there, and it's something we're seeking comment on the greenhouse gas inventory.
Okay.